Okay guys, here we got a Audi A4 2 litre 16 valve TDI PD engine, unit injectors, BRE engine classification, 140 brake. Came to me with a chronic underboost problem. Basically changed EGR valve, which is here, mounted on top of the throttle, motorized throttle body here. You can see our EGR pipe coming in here from our EGR cooler over here, which runs around the back of the engine. EGR basically stripped its gears inside there, probably due to failure of the sensor, contactless sensor just mounted up on top of that here, and probably all stemming back to oil ingress into the connector. This is full of oil when I got it, so EGR wasn't been working with a while. Led to coking up the turbo. We got a variable geometry turbo, Garrett GT17. So we took that apart, cleaned it down, cleaned the vanes, etc. Mounted back on the turbo. We also had a swirl flap mechanism here of a vacuum actuator with a pierced diaphragm. So that was losing a lot of vacuum coming from our vacuum pump here. So we were losing vacuum there. That's working now again. Changed that, whipped off the inlet manifold, cleaned it out. Also our VGT turbo actuator control valve. Somebody obviously broke one of the vacuum inputs here and tried to repair it. We were losing vacuum here as well, so we replaced that. So fingers crossed, when we replace an EGR valve, we're going to do an adaptation on it. So basically all the air that's coming in from our airbox goes through this our mass airflow meter, so the engine computer, the ECU, knows exactly how much air is coming in. And obviously if the EGR valve opens, it's recirculating in a bit of spent exhaust gas in there that it doesn't know about, so it's going to see a drop in its mass airflow, and that's how it determines what's happening with the EGR system and how much EGR gas to leave in. So we're just going to try adaptation with VCDS. Let me plug it in here. So ignition on, and we're going to select control module, engine, check for fault codes, unfound. Good. We'll go to basic settings, exhaust gas recirculation. Right, so you can see our spec exhaust gas and our actual exhaust gas. This is what the ECU wants, and this is what it gets. It gets that value by seeing the drop in mass airflow across the mass airflow meter, because now we're introducing spent exhaust gas in there, so it knows exactly how much is going to be coming in. And this is just our duty cycle for that flap, that motorized EGR valve. So we're going to turn on our engine. Okay, we're running. We're going to set her off. We're running. You can see she's in adaptation mode. Got her amber light flashing. You can hear EGR closing. It's closed full. It's building up back pressure, which is causing the turbo to spin up faster. We can hear it, and now it's letting it go. See the difference in milligrams per stroke there of mass airflow. again. And open. So the EGR, basically it's going to calibrate, if you like, probably PID loops running in the ECU. It's going to do this a couple of times. Side will hear the engine. Okay, so you can hear the back pressure. The turbo starting to spool up, obviously when the EGR closes this flap. Of course, the first thing I did with this engine was check it for oil pressure. These engines are notorious. They've got a lot of issues with their oil pump drive, hexagonal key drive, which gives us wears. Can destroy your engine. This model, the BRE, is a later one, so it's got gear driven balance shafts. Previous ones like the BLB were driven by a chain. Disaster basically. So before you do anything, if you've got a turbo issues or anything like that, you should always check your oil pressure. Oil pressure was good at this. 60 psi a tick over, and we're finished. And turn it off. Great stuff. Thanks for watching.